Okay, my dear student, we have been discussing chapter number 3, metals and non-metals, right? So in the previous videos we had discussed regarding the physical properties of metals and non-metals, right? You just remind their physical properties. You will be able to know that some properties we had considered, suppose lustrous, malleability, then ductility, sonorous, this thing, conductor of electricity, conductor of heat, these things were discussed, right, in terms of physical properties. Now let us come to the chemical properties of metals. Now chemical properties, here we will be getting to know that some reactions of metals with different kinds of substances, right? How the chemical changes occurs, or how the new substances are formed, what is the extent of reaction of different metals under different conditions, right? Now at first, what happens when metals bond in air, right? So metals bond in air, obviously if the bonding occurs, that means what, there will be the reaction with the oxygen. Now here we will get to know that how the metals react with oxygen. Now for this purpose, for the study of chemical properties of metals, some very well-known metals or which are widely used. Suppose you know that aluminium, copper, magnesium, zinc, sodium, these are some well-known and widely used metals. So we will discuss their properties specially to get the idea of their chemical nature. Now at first, as a whole, when metal react with oxygen, then the resulting product will be metal oxide. That means after the reaction of metal oxygen, that means oxygen will combine with the metal, and then oxide of that particular metal will form. If it is sodium, then sodium oxide. If it is calcium, then calcium oxide. If it is magnesium, then magnesium oxide. That means when metal react with oxygen, the resulting product is metal oxide. Now this formation of oxide for different kinds of metal will be different, right? That means the extent of reaction of different metal with the oxygen will be different. Suppose here you see, if we take an example, copper. If copper react with oxygen, the product will be copper oxide. If it is aluminium, then it forms aluminium oxide. So as a whole, when metals react with oxygen, the product is metal oxide. Now the formation of oxide for different kinds of elements, how its common formula will be, it depends upon its valency, how it will combine. Okay, that's known to you. Now if we recall, or if we remind the chapter number 2, then in that chapter we had discussed that metal oxides are basic in nature. That means what, if metal oxide react with acid, then the resulting product becomes salt and water. So metal oxides, somewhere they behave as base. That means their character is basic in nature. Now some metal oxides are there, like aluminium oxide or zinc oxide. Okay, they show both the property of acidic and basic. That means they can react with the base also, they can react with the acid also to form salt and water. So such kind of oxides which can show acidic as well as basic behavior is known as amphoteric oxide. So amphoteric oxide means what, those oxides which can behave both as acidic as well as basic, and the example can be considered as aluminium oxide and zinc oxide. Suppose here, see in this example, when aluminium oxide react with hydrochloric acid, HCl, right, the product is aluminium oxide and water. That means here in this case, for the first example, you see this aluminium oxide is acting as a base type, or here its behavior is basic in nature, because this, if it is basic in nature, and HCl, obviously it is known to us acid, then acid and base, salt plus water. That means the character of aluminium oxide in this reaction is basic. Okay, in the next reaction, you see when aluminium oxide react with sodium hydroxide, and you know the sodium hydroxide is a base, right? The product you see sodium aluminate plus water. So in this reaction, in the second reaction, the oxide of aluminium, this aluminium oxide is acting as a acid, or its behavior is of acidic. So aluminium oxide, acidic behavior, sodium hydroxide is a base, so reaction and the product is that sodium aluminate plus water. So from here it is evident that this aluminium oxide can behave both as acidic as well as basic, and such kind of oxide which can behave both as acidic as well as basic is known as amphoteric oxide. I think you have understood, right? Now some metal oxides are there. Most of the metal oxides are insoluble, they don't get dissolved in water, but some metal oxides like sodium oxide or potassium oxide, okay, they dissolves in water to form what? Alkalis. Okay, so the metal oxide like sodium oxide and potassium oxide, when they get dissolved in water, then the resulting base, the sodium hydroxide and potassium hydroxide, they are known as alkalis. So some metal oxides form alkalis after dissolving in water. Okay, next suppose so from here onwards we have got that the extent of reaction of different kinds of metal will be different, or they are showing different kinds of properties, the reaction with oxygen. Now the metals like sodium and potassium, the metals such as sodium and potassium, okay, sodium and potassium, they are kept immersed in kerosene oil. Okay, why it is done? Because these metals sodium and potassium, they are very reactive, and due to this more reactive nature, they react with the normal oxygen present in the atmosphere to catch fire. Hence, to protect or to prevent this accidental fire, it is kept immersed in kerosene oil, so that the sodium or potassium, they don't come directly in contact with the oxygen present in the atmosphere. Besides this, what happens at ordinary temperatures, that means at normal temperatures, the surface of zinc, aluminum, magnesium, they contain a layer of oxide. That means if it is magnesium, then a layer of magnesium oxide is found in case of magnesium metal. If it is zinc, then zinc oxide. That means at normal temperature they can react with the oxygen present in the atmosphere to form a layer of that particular oxide. Obviously, if the metals react with oxygen, definitely we have got the metal oxide will form. So if the metal is magnesium, then magnesium oxide will form, right? And this idea we got in chapter number 1 also, right? Why shall we remove there was a question, right? Why should we clean a magnesium ribbon before burning? This type of question was there, right? So that magnesium oxide layer is due to the reaction of magnesium with oxygen. Now one more thing is there here. Suppose the iron, okay, so iron doesn't burn on heating. Simply if we heat iron, it won't burn, but the iron filling, that means the pieces of iron, if it is sprinkled in the flame, then they can burn. Again, in case of copper simply it won't burn, but if the hot metal of copper is again coated, or there is a layer of black colored copper oxide. And silver and gold, they don't react even at high temperatures. That means what? So far whatever we have got the idea, it is clear enough that the reaction of different kinds of metals are different with oxygen. That means the extent or their attitude towards the reaction with oxygen is different for different kinds of metal. We have got for sodium and potassium, very reactive. In case of iron, copper, we got they simply don't react, but under a special condition they react. Suppose silver and gold, they don't even react at all. That means what? Their extent are different. And okay, one more process is there which is known as anodizing. Okay, so this anodizing process is what it is, the process of forming a thick oxide layer of aluminium. That means making a layer of aluminium, a thick layer of aluminium. And how it develops, and that means throughout the process of electrolysis, and why it is done, to prevent or to make this particular aluminium article resistant for further corrosion, right?